Hi class, let's go to the next evaluation that they're asking us to do. And in this case, this is just the median. Now, the median represents from the data set, technically the value that happens to be in the middle. If there's no value in the middle, then you're just gonna basically going to divide the data set into the two values that's in the middle. So if there was no middle, then the values that are in the middle will be added and divided by 2. So let me take a look. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. In this case, the median happens to be 40, since it's the value right in the middle, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now, you don't have to actually count this. This is given as you run the one variable stats. And in this case, the median happens to be already given in here as basically the values of 40, which coincides with that 40. So you could have just said on this one, since technically you're using the one variable stats, and this is the indication I'm using a TI-8384, that's the proper command. You would have just said on this one that the actual median is equal to the values of 40. And I'm assuming that you're going to be using the shortcut on the calculator. I wouldn't expect that you're actually looking for the value in the middle. All of these operations are already done automatic by the calculator. So that happens to be the actual value of the median. When we look at the range, so in this case, the range is going to be given by, well, the formula is here. It's going to be the max minus the minimum value. So you're going to see that formula here. Now, all you really have to do is give me the numbers. In this case, we're looking at the maximum. It's going to be 100 minus 5. If it's any other numbers that you need the calculator, please punch them in. So in this case, that's your maximum minus 5. Your range happens to be, well, technically 95. That would be your main answer. Perfectly fine to run everything on the calculator just to double check. Now let's take a look at the mid-range. Now your mid-range, it's going to be given as the min, technically plus the max, divided by 2. You have to be very careful on this one, because as you punch it into the calculator, in this case, the values of 5 plus 100 divided by 2. As you evaluate in your calculator, you have to make sure that you're basically putting parentheses, or otherwise it won't evaluate. So you would say parentheses 5, actually I didn't put the parentheses. So 5 plus 100, close the parentheses, divided by 2. Round to 4 decimal places, in this case 52.5. Let's take a look at the next problem. And the next problem, you're going to notice that you technically have the same data set, but now they're giving us another assumption. The assumption is that they're now calling this a population. Now, your formula that you're using in the values for the population, it's actually the same. So let's take a look and analyze it. Now, if we're defining this one to be the mean of a sample, that's x bar, that's the sum of the x's divided by n. But if you're calling this a population, which in this case is just an assumption, you would be using the variable of mu, which is equal to the sum of the x's divided by n. Now, you don't have to recalculate anything on the means for raw data. In this case, this is considered raw data because the data, it's basically as it was collected. So all you have to do for this one is basically say that the values of mu, it's equal to the sum of the x's divided by n. And then since the calculation is the same, you're not doing anything other than running the one variable stats. And what you're gonna find is that the actual value of the mean, and this is only for raw data, it happens to be the same as x bar. So in this case, we would say that that's 41 point. So 41 point, and this one is 45, 45. So 45, 45. It's a little bit confusing, but the only difference is that we're calling this particular data set now a population. And as I mentioned on previous videos, for most of the populations that we're going to be analyzing, we're assuming that they're very large data sets. However, it's possible that it's a new event, and in that case, the population happens to be small. Let's take a look at question B. Now, if you have the data and you happen to have a population, you can determine or estimate the actual distribution based on the mean and the median. So in this case, your median hasn't changed. Your median, whoops, let me use a different. So your median, it's equal to, we had a 40 there. That would be the values of 40. And then the actual mean, it happens to be 41.45. So in this situation, we're looking at the mean being greater than the median. To determine the distribution, another way that you could actually look is at any of these three scenarios, which situation you're in. In this case, the mean is greater than the median, so it's going to be skewed to the right. So you would actually say something along the lines, since the mean since the mean is equal to technically 41.4545 happens to greater than 40, which is equal to the median, then you would say that, let me just put a comma, it is likely that the distribution is, and we're talking about basically the last one, so it's skewed to the right. Let me just double check to make sure I'm not messing this up. Now, your final wording has to have something about likely, and this is because we're making the assumption that we technically have a population, but populations tend to be large or infinite. So we're always stating something along the lines of likely. It's possible that the situation could change. Now, the last one, they want us to provide a sketch of the distribution. It doesn't have to be very accurate as long as you basically have the units. So in this case, we're still talking about minutes. And this particular one happens to be technically skewed to the right. Your minimum value started at 5. So we're still looking at 5, and then it goes to the right. So as long as you have, well, the values of 5, and technically it's going to be something along this, so around here. Let me fix that arrow. So something along these lines. So the idea that it's skewed to the right actually refers to the fact that, well, if you have outliers, they're actually going to be somewhere on this side. So as long as you mention the units, and our units from this problem happen to be minutes. And that is actually it. All I want is a basic sketch. Skewed to the right mean it starts, in this case, 5, and then it goes all the way to the infinity. I don't want to put the value of 100 here because that may actually be misinterpreted as it's stopping. We typically just put an arrow. The actual outliers are going to appear on the actual right hand side. You may include the 100, but it's not needed to include all those values. All of these would be typically done by technology.